P.2quared Journal Entry 14. Today is October 30th, 2021. Time is 7:08 a.m. Today in the entry I want to talk about electron orbits and strong force and how those two fundamental forces under this hypothesis are just different layers of the same interaction between a constituent and a group of particles. So this is one of the things that bothered me about physics when I first started studying. I was like, how can an electron orbit a nucleus without flying off? And when I began to think of a mechanical way to explain how an electron can have an orbit around a nucleus, it's one of the things that led me to the shape of the helix constituent. When you look at a particle, a helix particle, and let's draw one of these guys. So when it gets ejected out of a group of constituents, the last interaction is going to cause it to have a nice little spin. And what happens is, if we were to look at the constituent from, let's say we're looking at it, we're this camera, so we're looking at this constituent, it would look like this to us. And what's happening is it's spinning this way. So as it's spinning, where is it? This way, it would actually be making that corkscrew motion that would allow it to pull a group of other constituents the next time it came in contact with them. I call that an energy packet. So if we were to look at it from a much bigger eraser, we were to look at this from a vector standpoint, let's come here. So let's say that it's facing this way, right? Which means that it's pulling this way and it's still spinning this way. And let's say it came in contact with another particle. This contact between the constituent and the particle would cause a single energy packet to move at the average velocity, the average vector of this particle in this direction. So what happens is you have, over time, this happen millions, maybe billions of times, which would cause a particle to have an orbit around its nucleus. So that electron is running into constituents here, and here, and here, and here, and here, and that's what causes that nice ring. Now, truth be told, it's not the chances are, when you look at the way constituents diffuse themselves out, it's not one particle, but it would actually be more of a field of particles that's being moved around this nucleus, and they're all just kind of interacting with the constituents that they come in contact with. Now, in this illustration, I drew them as if they were interacting with the first ring, but in all honesty, the first ring is more than likely where you're going to experience strong force, not experience an electron orbital shell. The reason being is that this is the highest concentration of helical constituents in this first ring pulling straight down, which is why when you have larger particles, they would get caught in each other's first rings, and they would create an intricate set of rings around them that the electrons would be existing in. So truthfully, if we were to draw it a little bit more honestly, you would probably see the first ring right around here, and this would be the strong force field, and this would be the electromagnetic fields. Yes, because every ring after this would act like every ring after this would act as a electromagnetic field from our perception with our current theory, not a strong force field. And the interesting thing about this little ring right here is that it is actually pushing any particles that try to get down into the strong force ring back out into the electromagnetic ring. And this would happen at every level, which is why we see electron orbital shells instead of just this one giant blob of electrons flying around the nucleus of an atom. So every time a electron wants to come down a level, so to draw it out, the next one, we go from pull, down, up, then we go back in, then we go down, then we go back up. This would be the start of the next ring right here. Because what's happened is the constituent is now pushing instead of pulling. So every bit of interaction that's happening in this zone right here is lending itself to taking is pushing any electron or any particle that's trying to get close back out of this ring right here and pushing it into the ring above. And that's why it takes so much energy to push an electron down a level, because you have to go through an entire wall of constituents saying, no, we don't want you to come in. So let's take a moment to clean up the screen. So this is what we're looking at when we look at how the helical constituent hypothesis maps out why we see what we see in a subatomic level. It answers and combines strong force and electromagnetic force together. So we'll wrap that up with this entry here. On the next entry, we'll talk about weak force and radiance. Because weak force, I think, is something that we can go over quickly. Radiance are huge because it allows us to explain gravity and photons and electrons and all that stuff. So we'll have fun with that. But that is it for this entry. We'll see you in the next one.